Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see a Leetcode medium problem 1300. Sum of mutated array closest to target. So let's read the problem statement. We are given with an integer array and a target value. We have to return an integer value such that when we change all the integers larger than that value in the given array to be equal to that value, the sum of the array gets as close as possible to that target. In case of a tie, if we have to return the minimum integer. So let's see with this example to make it more clearer. We are given with 493 as an integer array. The target is 10. So if we choose 3 as our value, then we will convert all the integer values greater than or equal to 3 with the value 3. So now the array becomes 333 and the sum of which is 9, and this is the optimal answer, because suppose if we choose 4, then the integers greater than or equal to 4 are 4 and 9. So we will convert 4 as 4 and 9 as also 4, and 3 is less than 4, so we will leave it. So the sum becomes 4 plus 4, 8 plus 1, 8 plus 3, 11. So 11 minus 10 is also 1. The difference is also 1, but we have to take the minimum integer, which is 3. So how to solve this problem? Let's see. So we will use a binary search to solve this problem. So I've taken this 493 as an array. So from the start, as we know, binary, for the binary search we have to take a min and max, or left or right. So initially we will take max, the maximum element of this array, and minimum as 0. So for the first iteration, our min is 0, max is 9, the mid becomes 4. So we will choose 4 as a value, and we will see in this array what are the integers greater than or equal to 4. So we see that 4 and 9 are the integer values that are greater than 4. So we will convert 4 and 9 to the value 4. So and make a sum of this array. So that this will be 4 plus 4 plus 3. And the mutated sum will be equal to 11. So now this 11 is greater than our target value, that is 10. So we have to reduce our max to find the lesser value which is closer to our target value. So now the max becomes mid minus 1, that is 3. Now we will calculate the difference between the target and the sum. So as we have seen, if we make a sum of these 3 integers, the difference is 1. So we have already initialized our diff to the int max. And if the difference is less than or equal to int max, we'll assign the diff as 1, and the result is the value, that is 4. Now for the second iteration, we have reduced our max to 3 and min will remain as 0, because why we are reducing our max to 3 is because we want the element as close as 10, or equal to 10. So we will again try whether we can find a value for which the mutated sum might become equal to 10 or might become equal to 9, because the difference between 11 and 10 and 10 and 9 is also 1. So we will choose the value for which the mutated sum became 9. So let's see, in the second iteration, the max is 3 and min is 0. The mutated sum will become 3. That is, the mid, will calculate the mid of max plus min. So 3 plus 0 divided by 2 will be 1. So mid is 1. So we'll see the elements in this array greater than or equal to 1, and we'll convert all these elements to 1. So it will be 1 plus 1 plus 1, that is 3. Now we will see whether this sum is greater than target or less than target. So this sum is way less than target, so we have to increase our minimum to move it more closer to the target. So we will increase our min to mid plus 1, that is 2. Now we will calculate the target minus sum, that is 3, because our target is 10 and the mutated sum is 3. So our target will be 7, which is not less than or equal to the previously calculated diff. So we will not update the diff and the result will not get changed. Now we will again see that the max is 3, min is 2. We'll calculate our mid. That will be 2. 3 plus 2 divided by 2, 2 integer value. Now the mutated sum will be 6, because we will convert all the values which are greater than or equal to 2 with the value 2. The mutated sum became 6. Now the sum is still smaller than the target value, so we have to increase our minimum to reach more closer to the target value. Now we will calculate our target minus sum difference, that is 10 minus 6, that is 4. That 4 is still not less than the previously calculated optimal difference, that is 1. So we will not change our difference and the result will not get changed. In the last iteration, we have converted our min to 3 and max to 3. So our mid will be 3. We will convert all the values greater than or equal to 3 to a value 3 and make it and calculate the sum of all these integers. That will become 9. And as again we will see that 9, the sum is smaller than the target 10. So we want to reach as close as to the target or equal to the target. So we will again increase our minimum in a hope to reach to a mutated sum that might become 10. Now we will again make a difference of the target and the sum. Now here we got 1 again. So if we see that the difference is equal here, so here is an important point. Whenever the difference becomes 1, like in this case 11 and 9, that our mutated sum, and the difference is absolute difference between 11 and 10 and 9 and 10 is 1, we have to choose the value where the value which is less, that we have to choose. So now if we see here, the earlier result was equal to the mid value as 4. Now for this iteration, our mid value is 3. So because mid is less than the previous result, we will make change to our result value, which will be the current mid value equal to 3. So that's the important point. Now let's see the coding part. So here we have initialized our max value to the min value, and we will calculate the maximum value for the starting iteration, first iteration, the max value from this integer array. If the sum is equal to target, we'll return then and there, and we'll say that the max is our actual value. If the sum is not equal to target, then we'll perform a binary search. Just an important point, the answer would always lie between the 0 and the maximum value in the array. So it's a simple binary search where we will iterate till the minimum is less than equal to max. We'll calculate for each iteration the mid value, and we will find the mutated sum. So the mutated sum is the sum with a value for which all the integers larger than the value in the given array to be equal to that value and make a sum of it. So if the sum is greater than target, we have to update our max to mid -1 so that we can reach as close as to the target. Else, if the sum is smaller than the target, we'll try to increase our minimum value so that we reach as close as to the target in both the cases. So here is also one important point, as I showed in the example, this criteria, that if the difference calculated earlier, if the current difference from the sum and minus target is less than the difference, we will update our difference. Or if the difference, previous difference, is equal to the current difference, then we'll check the value, the mid value is, if it's smaller than the result stored earlier, then we'll update our result as mid, and lastly we'll return our result value. So if we talk about the complexity of this algorithm, it will be n log n, because for the binary search it's log n, and for every value we are going with an big O of n iteration. So thank you for watching this video. Let's see in another Leetcode video. Till then, bye.